Okay, so with that session, let's begin our lesson. So we are going to continue with chapter 5 about chemical kinetic. So before we begin, so if you like this video, do click the like button. And if you want to receive further notification about my latest video for the STPM chemistry solutions, you can always subscribe and click the notification buttons for further information. Okay, so with that session, let's begin our lessons today. So we are going to continue with the section C of the questions, which we are going to learn how to write essay questions. In here, I'm going to show you on the technique of how to tackle the questions, so that you'll be more prepared to answer as much as you can. So let's begin. Number one reactions which occur in air polluted with nitrogen oxides are 2NO plus O2 give 2NO2. The table below gives the result of 3 experiments carried out to study the relationship between the initial concentration of NO and O2 and the initial rate of the formation of NO2. So these are the experiment 1, 2, and 3. These are the initial concentration of NO and O2. This is the initial rate. Now, based on the study above, deduce the order of reaction with respect to nitrogen monoxide gas NO and oxygen gas O2, hence deduce the overall order of reaction, 6 marks. And from 1, write the rate equation and calculate the rate constants for the reaction, 3 marks. So I'm going to solve this method. Now, what I'm going to show you next is the technique of how are you going to answer for such questions. So my advice for you, you follow exactly of what I told you, and you I can assure you, you can get to your maximum marks for this type of the questions, okay? Okay, so first of all, you have to write the mock rate equation. What is the mock rate equation? The one without the order of reaction. So you put as unknown A and B. So first you write rate equals to K, concentration of NO power of A, concentration of O2 power of B. Then you substitute for all the 3 experimental value inside the rate equation written, where in experiment 1, you have 4.43 times 10 power negative 3 equals to K, 0.62 power of A, 0.024 power of B. In experiment 2, 1.10 times 10 power negative 3, K, 0.31 power of A, 0.42 power of B. And in experiment 3, 8.86 times 10 power negative 3, K, 0.62 power of A, 0.48 power of B here. So in order to get the order of A and B with respect to NO and O2, so you need to compare in between experiment. So in order to get power of A, you have to compare experiment 2 to experiment 1. And then if you want to get the order with respect to B, which is O2, you compare between experiment 3 to experiment 1. So this is the result that you compare. So 4.43 times 10 power negative 3 divided by 1.11 times 10 power negative 3 equals to 0.62 over 0.31 power of A, whereas we have 8.86 times 10 power negative 3 over 0.11 equals to 0.62 power of 31 square over 0.42 power of 24b. So in here, you can already get that A is square. So since A is square, that contributes to the order of reaction in here to 2. So this will get your B is equals to 1. Okay. So that is how you are going to find out eventually the order of reaction with respect to NO and O2. So if possible, you write concentration, order of reaction with respect to NO is second order, order of reaction with O2 is, with respect to O2 is first order. And then don't forget, the question also asks you to calculate the overall order of reaction. So the overall order is 2 plus 1 equals to third order. So that is how you calculate for number A. So remember the technique. First, write the mock rate equation and substitute all the experiment, compare in between the experiment in order to get the order of reactions and calculate overall order of reactions. So number 2, you need to calculate the rate of reaction and then calculate the rate constant. Yeah. So you take any experiment. So let's say I let experiment 2. So 1.11 and then about negative 3 equals to K 0.31 square multiplied by 0.024. So substitute, you get your K equals to 0.481 mole minus 2 dm power of 6s minus 1 in 3 significant figure. So how do you know that we are in 3 significant figure? Because if you look back at all the questions, they all uses 3 significant figure for the answers. So your answer should also be in 3 significant figure. So that is how you answer for A. So immediately we go to B. Nitrogen dioxide formed when released to environment promote the formation of sulfur trioxide via the oxidation of sulfur dioxide. 1. Explain how nitrogen dioxide speed up the oxidation of sulfur dioxide to become sulfur trioxide. 4 mark. And state the effect of the environment of formation of sulfur trioxide. Now this is something that you have to eventually know on how to explain. It is in the syllabus, so you must be able to express. Where in here, nitrogen dioxide in here actually act as a homogeneous catalyst because nitrogen dioxide is a gas, sulfur dioxide and sulfur trioxide are also gases. So this happened in the stratosphere layer, where in the stratosphere layer, nitrogen dioxide catalyzed the reaction by first oxidizing SO2 to become SO3 according to the equation. SO2 plus NO2 give SO3 plus NO, and then the NO is oxidized by the oxygens in air, so you form back the NO2. So eventually you cancel NO2 cancel with NO2, NO cancel with NO, you get the overall equation of SO2 plus half O2 give SO3. So this is how the sulfur dioxide oxidized to become sulfur trioxide with the assistance of the nitrogen dioxide in here. Okay, so what is the effects towards the environment? So it produced the acidic rain by reacting with water according to the equation. SO3 plus H2O give H2SO4. So if you want to add more, so the acidic rain makes the soil become acidic and corrodes the buildings. So these are all the possible effects to the environment caused by the sulfur trioxide. Okay. Okay, so that is for question number 1. Then we go on to question number 2. Activation energy A of a reaction can be calculated based on the Arrhenius equation where K is equals to A epsilon negative A over RT. In an investigation, the rate constant of the gas phase decomposition of dinitrogen oxide N2O into its elements are measured at 5 different temperatures. The results are shown in the table below. You have the temperature given in Kelvin, and then you have the rate constant in here. So if you look carefully, the unit of the rate constant is S minus 1. So you have to be very careful on how to determine the order of reaction based on the rate constant. So A1, what is meant by rate constant? Mark. And then what is the order of reaction? So justify your answer, 2 marks. And then B, by plotting a graph of ln K against 1 over T, determine the activation energy for the reaction above, 8 marks in here. So I'm going to solve this question. So let's start from what is meant by rate constant. So rate constant is the proportionality constant of the rate equation, which relate the rate of reaction to the concentration of reactant. If you want to further power by a certain order of reaction under constant temperature also can. So it's up to you on how you want to complete your sentence. But these are the minimal requirements on how to define rate constant. Okay. Okay, number 2, as I mentioned just now, from the unit of the rate constant, you can determine that it is a first order because the unit of the rate constant is second minus 1. Now, in this question, they are very nice to you because they give you the base for the Arrhenius equation. However, you have to learn on how to derive the Arrhenius equation on your own. So you have to first derive the Arrhenius equation K equals to A epsilon negative E over RT to become ln K equals to negative E over RT ln A, not log and ln. Sorry for the typing error. So then you plot a table, change the K to ln K, change the T into 1 over T. So you get this table. So once you have this table, okay, you do it, okay, and then you start to plot inside the graph. Usually the graph is 3 marks. If possible, label this is ln K, this is 1 over T. Now, in here, I would usually advise students to put at least in 3 significant figures. Okay, sorry, pardon me to put only 2, but if possible, put 3 significant figures because that is the minimum requirement for STPM. And if possible, in here, you will notice that the x-axis do not start from the origin. You can always start from the minimum number, which is 0.89 in here. Okay, so now because this is a computer sketch graph, so you can see how accurate that can get. So in here, this is how you get graph. Okay, so usually in STPM, the graph is quite accurate. So you eventually have to carefully plot your dot and connect the dot based on the in here. You get a negative gradient here. Okay, then after that, you based on this graph, you get the gradient from this graph. So you take any 2 points that you like. So once you take any 2 points that you like here, okay, you can eventually calculate for the rate constant here, where the rate constant is equals to the gradient. Okay, so not the rate constant, but to calculate the EA over RT is the gradient of the graph in here. Okay, so you have to know on how to deduce that. Okay, so eventually you get any 2 points to calculate the EA over R. Okay, so gradient is equals to A over R, you get any 2 points, and eventually you can get your answer activation energy. So you have to multiply R is equals to 8.31. So you get 255 kilojoule per mole, or 2.55 times 10 power of 5. The accepted range in here is 240 to 200, and the accepted range in here, if I'm not mistaken, is 200, 2.4 to 2.6. times 10 power of 5 joule per mole. Okay, so this is the accepted range for this time's solution. So hopefully you'll be able to get it correctly. Okay. Okay, so that is how you are going to get for this answer in here. Okay, so that is for number B. So I repeat, you have to first derive the Arrhenius equation to become ln K equals to negative EA over RT plus ln A, not log and ln. So change the K into ln K, change the T into 1 over T. So you plot the table, okay, from the table you plot the graph, and then you calculate the activation energy here. Okay, so that is how you're going to calculate the rate constant here. Okay, then the B2, based on the graph which you have plotted, calculate the half-life of the above reaction at 590 Kelvin, 4 marks here. So you have to first calculate the 1 over T. So at 50 Kelvin, so 1 over T is 1.0 times 5 times 10 power negative 3. So back on the graph in here, 1.05, where is it? So you have to try your best to get 1.05, which is in the middle of here. Okay, so you get what is your ln K in here. Okay, so once you get your ln K, okay, you get somewhere between 0.2 something in here. Okay, so you have to anti-log your graph. So when you anti-log your graph in here, so you get somewhere in between 0.0970907 second minus 1. And then because this is the first order of reaction, so you have to use the half-life rate equations. So you use T half is equal to 0.693 over K. So you have 0.693 divided by 0.0907. So your half-life is 7.64 seconds in 3 significant figures. So that is how you are going to calculate the half-life for the reaction. You have to use this technique. So similar question were asked in STPM 2015, 14, sorry, STPM 2014, under the same technique. So this is the way of how you are going to answer for question number 2. Then we are going to continue with essay question number 3. Peroxyacetyl nitrate PAN is an air pollutant formed from photochemical smoke. Concentration of PAN in a polluted air sample is analyzed at 25 degrees Celsius. The results are given in the table below. You have time and concentration. So note that the time is minutes. Okay, and the concentration is time 10 power negative 10. So sometimes in the questions you have to be very sensitive with all the values in here. So this is time 10 power negative 10. So therefore later in your answer, anything that has related to the concentration you have to express as time 10 power of negative 10. Okay, so number 1, determine graphically in order of the decomposition of PAN at 25 degrees Celsius format. So you plot the graph of concentrations against time. So if you plot the graph of concentration against time, so eventually you have to you get 0 here. I'm so sorry why I didn't show why the graph shows like that. Okay, so sorry for that. So it's supposed to fix to the origin here. Okay, so you use the half-life method. So if you use the half-life method, half of the 8.4 is here. So you get 402. Okay, you get certain order of you get certain half-life, and then you get another half-life at 0.21. Okay, something like that. Okay, because the graph in here is not plotted nicely, so you get not a very accurate result. I'm so sorry for that. But eventually, when you plot the graph carefully, you will be able to determine that the order of the reaction is the first half-life is equals to the second half-life. Therefore, the order of reaction is first order with respect to pan. So that is how you are going to determine graphically from the concentration against time on how to determine the order of reactions in here. Okay, so that is for question number 1. And then question number 2, calculate the half rate constant for the decomposition. So let's say if you use the graph, you eventually manage to calculate the half-life is 30 seconds. You can eventually deduce half of the 8.4 is 4.2, 30 seconds. 4.2 is 2.1, 60 seconds. So it is a first order of reactions. You can more or less estimate that. Okay, so therefore K is equals to 0.693 over 30. So you get your order of reaction, rate constant is 0.231. Unit is minute minus 1, and this is minute, not second. Sorry for the typing error. If you use the graph tool, you calculate the gradient of the graph. So no, this one, sorry, no graph tool. Okay, and then number 3, what are the half-life concentration after 3 minutes? So pan is equals to 8.4 times 10 power of negative 10 times first half-life times second half-life times third half-life. So you get to divide, multiply by 3 times half. So you get 1.05 times 10 power of negative 10 mole per decimeter cube. So that is how you are going to determine the order of the reactions. What is the concentration after the 3 half-life in here? Okay, and finally B, the first order rate constant for the decomposition of dimethyl ether CH3 bracket 2O gives CH4 plus H2 plus CO is 3.2 times 10 power negative 4 seconds minus 1 at 450 degrees Celsius. So from here is first order. The reaction is carried out in a 1.00 decimeter cube flask. Initially contain dimethyl ether presence and the pressure is 35.5 kilopascal. What is the pressure after 8 minutes in here? Okay, so you have to be very careful with the interchange of the unit because the rate constant is in second minus 1 and the system is asking is after 8 minutes, so you have to eventually convert minutes to become second. So these questions because they specifically want what is the pressure after 8 minutes, so the works is going to be quite long because first of all you need to calculate mole. From the mole, then you have to relate with concentration. And then after you get the concentration at 8 minutes, you have to convert back to become pressure so that you are able to calculate. Now, maybe if I just explain like this, you won't be able to understand. So it allows me to show you the step-by-step of how to solve this question. So first of all, you have to use this ideal gas equation where you use PV equals to nRT to calculate the initial mole of the reaction. So you get N is equals to PV over RT. So P is 35.5 times 10 power of 3. Your volume must be in meter cube. So 1.00 times 10 power of negative 3 divided by 8.31 times the temperature, 298 degree Kelvin, 450. So this is 273. Sorry for that. 273 supposedly. Sorry. Typing error. We'll correct it. Okay, so eventually you get your mole is 0.00591 mole. And then after that, you use the first order equation where you have ln CH3 T equals to negative KT ln CH3 So this is the initial moles in here, 0.0591. So you substitute. So your rate constant in here is 3.20 times 10 power negative 4. Substitute as exactly given to you in the questions. I forgot to mention that. And then this one you have to then divide to concentration 1.00. Sorry for that. Okay, so negative 3.20 times 10 power negative 4 times 8.0 times 60 in second, then ln 0.00591 divided by the volume 1.00 decimeter cube. So you get your ln concentration of T is equals to negative 5.28 mole per decimeter cube. This is ln, and then you anti-ln to get your concentration is 0.005068 in here. Then after you get your concentration at the 8 minute, so you calculate how much of the concentration has decreased. So here, if you look at the equation, 1 mole of gas produces 3 mole of other gas, CH4, H2, and O2. So after 8 minutes, so CH3O2 decreased by how much? You decrease by 0.00841. So since stoichiometrically, 1 mole of gas convert to 3 other mole of gases, so you get your total product of the gases is 0.252 mole per decimeter cube. Then you have to add up with the remaining of CH3O2 because this is also a gas, don't forget. So you use P equals to N total RT. So P is equals to 0.005608, which is from here, plus the total gas produced 0.00252 multiplied by 8.31 times 723, which is from here. So divided by 1.00 times 10 power negative 3, which is the volume of the gas. Okay, so you get your pressure is equals to 45.6 kilopascal. Now that's why I said that for this kind of the question, if you are not sure the trick on how to solve this kind of question, so it is wiser for you not to solve this kind of essay question. But if you understand the principle of the first order of reaction, and then you understand the equations, what is the order of reaction, eventually you can go ahead and try. But this is the step-by-step guidance of how to get to the solution to calculate the P total after 8 minutes here. Okay, so that is how you solve for question number 3B. Then we are going to advance to the next question, number 4. What do you understand in terms of rate equation, order of reaction, and rate constant? 3 mark. And the acidic-catalyzed hydrolysis of ethyl ethanoate in water may be represented as below. The following were obtained from 2 such hydrolysis reactions. So these are the 2 different time at different concentration. So this is the time concentration of the CH3COO-C2H5 with the concentration of the acid used at that time is 0.1. So this is a graph. And then this is the graph of concentration of CH3COO-CH2, C2H5 and the concentration of the acid used in here. So acid in here actually serves as the catalyst. So where you get 0.200. So this is the graph of the concentration. So question number 1 will ask you like this. On the same axis, plot the graph of concentration of CH3COO, C2H5 against time for both HCl 0.100 and 0.200 mole per decimeter cube respectively for once. Okay. Okay. So what do you understand in terms of rate equation? So you have to learn how to define first. So rate equation is expressed the relationship of the rate of reaction to the rate constant and the concentration raised to some power. That is rate equation. Then order of reaction is the sum of the power to which all reactant concentration appear in the rate of log are raised, and the rate constant is the proportionally constant that relates between the rate of reaction in the concentration of reactant raised to some power. So these are the 3 very basic definition of the rate. So hopefully you'll be able to define accordingly. Yeah? Then we continue with B. You have to first plot the graph of the questions. So once you plot the graph of the questions in here, okay. So the blue line here represents for concentration of HCl at 0.20, while the green, 0.10, while the green line here is representing HCl at 0.200. So you get 2 different graphs in here, okay. So after you plot the graph, you need to calculate initial rate. So initial rate in here, so the initial rate for the first graph is 3.5 minus 3.0 times 10 power negative 3 seconds. So you get this rate initial rate. And then for the second graph, you get the initial rate for this one. Okay. Now, if you have my module inside one of the examples, I also shows you on how to calculate for such question. So if you cannot understand, you can always refer back to the module where I also explain the same thing. Okay, and then you also need to determine what is the order of the reactions. So the order of the reaction, so 0.2 half-life is 0.1, so you get 0.1 in here. So you get certain time. So let's say in this case is 0.7, and then a half-life of 0.1 is 0.05. So you get this one certain times again. So if you look carefully at the times in here, and then 0.5, you get 0.25. So 0.25, you can get another graph here. So if you look carefully at the timing in here, it is like 31 seconds, 62 seconds, 90, 3 or 94 seconds. So the first, based on this half-life, you can more or less predict that it is a first order with respect to CH3, COO, C2H5. And then you can make use of the rate equations in here to calculate the order of with respect to HCl. So with respect to HCl in here, you can eventually get that it's the first order of reaction. Hence, the rate equation is equals to rate KHCl CH3CO C2H5. So this is a combinations between how do you use the concentration against time to get the order for CH3CO, C2H5, and then you use the rate law methods to get to the order of reaction with respect to HCl. Okay, so these are the two combinations of the two methods in here. So hopefully you'll be able to understand in here. Okay. Okay, so let's continue to the next question. So that is how you're going to answer for both of the graph in here. Okay. Okay, so with that, that is for question number 4. Last but not least, question number 5. Hydrogen sulfide is a pollutant that exists in the water of industrial waste product. By using chlorine, hydrogen sulfide can be eliminated from the water of industrial waste by using the following equation: H2S plus Cl2 give S plus HCl. So the rate above of the reaction is first order with respect to each reactant. That means H2S is first order, Cl2 is also first order. Number 1, determine the overall order of reaction, 1 mark. Number 2, determine the rate of disappearance of hydrogen sulfide at 28 degrees Celsius if the value of the rate constant is 3.5 × 10⁻⁻2 decimeter cube, and the concentration of H2S and Cl2 are 1.6 × 10⁻⁻4 and 0.07 mole per decimeter cube respectively. Now, if you look carefully at all the values in here, they are all showing 2 decimal place or 2 significant figure. Therefore, your final answer should also be 2 significant figure. And then finally, number 3, calculate the rate of formation or concentration of HCl under the above reactions, 2 marks. So first of all, you have to determine, this is the second order of reaction. So how do you determine the rate of disappearance? First of all, you have to write the rate equation. So rate is equals to K H2S times Cl2. So you substitute 3.5 × 10⁻⁻2 multiplied by 1.6 × 10⁻⁻4 at 0.07. So you get rate is equals to 3.92 × 10⁻⁻7 unit is mole per decimeter cube per second. Then the rate of disappearance towards the H2S in here. So H2S is half of the DHCl dt. So if the concentration of the HCl disappear in here is 3.92 × 10⁻⁻7, which you get number 2. So the rate is equals to 2 times 3.92. So eventually you get 7.84 × 10⁻⁻7. Since in 2 decimal points, so it's 7.8. 7.8. Okay. 7.8. Sorry for the extra significant figure in here. So it's 7.8. Pardon me here. So so this is a very direct questions on how to calculate the rate of reaction with respect to HCl, and also how to get the rate of disappearance of H2S in here. Okay. So this is for 5A. And then for 5B, peroxyethanoyl nitrate CH3CONO2 is an air pollutant that found in haze, irritate eyes, and harmful to plant. The compound is unstable and decomposed in the following equation: CH3CH2COOO and 2 gives CH3COO radical plus NO2. So the rate constant of the decomposition of peroxyethanoyl nitrate is 0.023 milli-1. Determine the half-life in here. So in here, the order of the decomposition is first order. So how do we know? We tell us from the unit. So the unit is minute minus 1. Okay. So you use the half-life equation. T half is equal to ln 2 over K, or 0.692 divided by 0.23. You get 30.1 seconds. Okay, so C, it is believed that compound of chlorofluorocarbon are responsible for the depletion ozone layer via the reaction below. So O3 plus Cl gives ClO plus O2, then ClO plus O gives Cl plus O2. Right, overall equation explain the role of chlorofluorocarbons and the mechanism involved. So the overall order of reaction, if you notice carefully in here, so you can eventually cancel Cl with Cl, ClO with ClO. So the overall order of reactions in here, sorry for that. The overall order of reaction is O plus O3. O plus O3 give 2O2. Okay, so CFC provide the free chlorine radicals in here. So this one is a little bit more on application. I'm so sorry you have to memorize this. So it produces the free chlorine radical, which will unstable and reactive. So the unstable chlorine radical will react with ozone to propagate to another chlorine oxide radical. So termination occur when two chlorine radicals occur. Okay. Okay, so I know that such questions are very applications questions and most of the students won't be able to understand. The advantages is more towards for SEM 1 repeat student because they already learned it in organic chemistry. I'm sorry for that. So I believe that is all for the essay question that I can show you. So hopefully you like my video and I'll see you on our next chapter, which is chapter 6. We're going to explain for further details, okay? So I guess that is all for our lesson today. So see you all next week. Okay, see ya. Bye.